All right, in pre-calculus 30, we're going to talk about section 1.2 today, reflections and stretches of functions. We just got through learning about horizontal and vertical translations, and before we get into reflections and stretches, I do just want to show you this graph right here, okay? So what we have here is we have, and I'm just going to, okay, in green, you see down here, we have the graph y equals x squared. So this is a parabola, vertex is at the origin, and h and k that we've already discussed in 1.1, h is 0 and k is 0. So if I light up this graph again, and k being 0 and h being 0, it's identical to the y equals x squared graph. So what we learned about in 1.1 is that if k changes, and here's k is now changing, if k is changing, then the vertical translation of this graph is changing. So it goes down, and as k gets larger, it goes up. Okay? Notice that the parabola is not changing shape. It's just changing vertical orientation. Okay? So if we bring that back down to 0, and we look at how h changes the graph, if we vary this parameter in here, it changes left and right. And if we change both of them at the same time, you'll see this graph moves, in a diagonal way, or has a left component and a negative component here. And then as this moves, when h and k both become positive, it has a movement to the right and a vertical up movement as well. Okay? So again, not changing shape. Today what we're going to talk about is the graph changing shape. All right? So let's just X that one out, X that one out. Let's go back to our notes. Reflections and stretches. Okay, so 1.2 in your textbook there, we're going to talk about what happens when we have a reflection. First of all, reflections in about, now when I say a reflection about the x-axis, that means the same as a spinning around the x-axis. Okay, it's like the x-axis is the mirror, right? So if we have this graph right here, okay, what we're going to do is we're going to take a minute, and I am going to ask you, what does this graph look like if we flip it in the about the x-axis? So that is a vertical flip, okay? So each point, this x-axis is like a mirror. So that's 1, 2, 3 units down. The next point would be 1, 2, 3 units up. If you remember from last section, the image point is stated like this, A prime. Okay, the image of A is A prime, and that's what is there. Okay, so if we kept doing that with the other points in the graph, we would start to label this graph like this. So C, oh, where does C flip to? It doesn't move, does it? Because it's right on what would be the mirror. So C and C prime are identical. We're going to have a name for that point in a few minutes here, okay? Now D flips the other way. So D is 4 units from the x-axis, so we got to go 4 units down from the x-axis. This is D prime. And E, of course, flips the other way, and it goes back up here. E prime. Okay? Now, if we connected these dots, and forgive me that my lines will not be perfectly straight, but if we connected these points, what we would get is we would get the graph that would be the reflected image, and I got to go through 4 right there, 4, 0, don't I? Because that's a point that wouldn't move either. And what I want you to notice, it would kind of look like this. Let's just try and clean that up a bit. Oh, I missed it. It would look like this, and the other thing is we've only selected a certain number of points, right? Like A, B, C, D, and E. But it is important to note that any other point that we pick on the original graph would have a reflection point in the other graph. Any point. This one right here would be reflected to right there, and so on. So it's the collection of these points. That's why I can draw the solid line, right? So this one would reflect down here, and so on. So does that make a little bit of sense there, that we have the graph looking sort of like this, the reflection about the x-axis? Okay? Now what I want to point out is I just want to list a few of these points here. So this point A is what? What's the coordinate for this point? -4 what? -4, -3. Okay. Now what is the point for what's the image point there? What is the coordinate here? -4, +3. That's true. Okay. Let's pick another one. What about B? What's the coordinate for B? -2, -3. Okay. -2, -3. What is the coordinate for the image point B? -2, +3. Okay. Now, I'm not sure if you are noticing a pattern yet, but let me give you one more. This is 3, 4. And D is, the image point is going to be 3 and -4. Does anyone see a pattern? What is the pattern here between a point and its image point in this type of reflection? What is it? The y-coordinate of the point flips signs. Anyone else see that? You guys see that? Yeah? Okay. So in every point, the y-coordinate is the opposite number. It flips signs. So if the blue graph is y equals f of x, right? We said that the y value of the point, okay, so that has points x, y, those are the coordinates for those points. We said that the reflected graph, and that is reflected about this x-axis here, has the points x, negative y. So the sign is opposite. So if y is negative, then we can write this, the reflected graph, as y equals negative f of x. So what this means is this. So let's write this, a little bit of notes down. If, excuse me, if a graph is reflected about the x-axis, okay, the equation for the reflection will be y equals negative, and I'm going to put -1 here, -1 times the original graph f of x. So that's why it shows up just negative f of x. You're basically taking every y value and multiplying it by -1. Okay. So it's pretty easy to find the reflected point. We just change the sign on the y, and that is true for everything. Now, I did mention that I was going to talk to you about this point that doesn't change. There's a special name for that point. If in any transformation, okay, we have a point or points that do not change, there's a special name for them, and that special name is this. C, okay, that is called an invariant point. And you think about that word, invariant, okay? If something is a variable, okay, if it varies, that means it changes. If something is an invariant type point, that means it doesn't change. So that point is the exact same. Do we have another invariant point that you can see for this graph? You should notice this one right here. It's not labeled with a letter, but this point is also an invariant point. You see that? It's the same point for both of these graphs. Okay, so that's invariant. So what we're going to do now is we're going to flip to Desmos here. So what I've got is, now let me just see which one I have to use here. Okay. All right. Okay, yeah. Let's see. Okay, so this one right here, this one and this one. Okay. All right, so this in green, now you can't really see it, I'll eliminate this. There's the green one, okay? That's y equals x squared. So that's like y equals f of x, and the f of x just happens to be x squared. Now, if I put another graph in here, okay, and I can change this value. Right now, a is 1. See that? And so that's the same graph. It's right on top of the other one. If I change this a value to -1, here it goes, going to -1, what happens? It flips about the what? About the x-axis. So when the y values all change, we have a reflection. So let's just check it out. What is this point right here? Okay, no, let's find some nice. Oh, there was 1.5. Okay, so about 1 point. Oh, come on now. Well, whatever. Hello. Okay. This one right here, right on that line, is about -2.24 and +5. See that? If I go right down here, this is -2.24 and -5. You see that? Now there's a way I can put those points on there, but it's not working right now. So any y value, let me just see here. Let me get that to stick. Okay, whatever. So 3.87 and +14.9. Okay, 3 point. Oh, it's not going to be on the screen there. Okay, 3.87 and -14.9. See that? It's a flip. All right, so let me show you that one more time here. From -1 to +1, it flips back to itself. Okay? Got it? All right. Questions? Now you're also seeing what's happening when we adjust this a value, not just -1, +1, but you see what's happening? We're changing the shape of this graph. So there's a equals 1, there's 2, and so on, 3, 4, 5, and so on. So we're actually getting a bit of a hint as to what happens here when we stretch things as well. But we're just kind of focusing on reflections here first, okay? All right. That's a reflection about the x-axis. Can we also reflect this about the y-axis? Is that possible? Yeah? Okay, so let's just see if I can get this graph to copy. Oh, beautiful. All right. Okay, so we reflected it up and down, and what we're going to do now is we're going to reflect it left and right. Okay, so just take a moment to just kind of sketch this out in your book again, okay, because we're going to do the same little exercise that we did before, except we're going to flip it the other way. Okay, I'm just going to name this reflection about the y-axis now. Okay, so we'll go through this just a bit quicker, I think. A, instead of reflecting up about the x, we're going to reflect over here about the y-axis. So this is -4, -3, so we got to go over here, and this is going to be what? That's 8 prime, and that's going to be what? +4, -3. Okay. What about B? Well, a reflection of B is going to be right here. That's B prime. And that point is going to be 2, -3. And so on. So if we kind of keep doing this, again, I'll go a little bit quicker here. And E is all the way over here to 5. Okay. All right, so again, I'll try and do this as best I possibly can. Straight lines of this here tablet. Oh, I didn't do C. Sorry. Thank you. Yeah, C is going to be over here. Thank you. And then B. And then there. Okay, so it's flipped. So it kind of looks like an M. Hey? M. Nice. Okay, so if we compare some points here, and let's just take a look at A and B. So A we said was -4 and -3. And over here it's +4 and -3. B is -2, -3, and over here it's +2, -3. So what is changing if we reflect this way? The x value, yes. All right. So if we have in blue y equals f of x with the points x, y, right? All those points on there would be x, y. We know that the green is y equals, and the x value has changed, so we put the negative sign right here. It's the opposite. So it's inside the brackets with the x. Okay? And that's going to make negative the version of the x value, or -1 times whatever that x value is, okay? So it makes it positive. Yes, so this is a reflection about the y-axis. So that's a sideways. Now, it kind of seems a little bit opposite. Some students have noticed this in the past. They're like, okay, if the y-axis is the mirror, why do I have to change the x values? That's tough to remember. Why don't the y values change? Well, it's because between left and right, you see, this is the x values that give the left coordinate and the x value that gives the right coordinate. So when you're reflecting about the y-axis, it's the x values that flip. When you're reflecting about the x-axis, it's the y values that flip. Okay? All right, so let's just jot a note. So when a graph reflects about the x-axis, the equation of that reflection, if the original graph is y equals f of x, then the new graph has the form y equals f of -x. Okay? So the x values are all multiplied by -1. And I could have put a -1 times x inside there as well, just like I did above. Okay? Okay? Now, let's go back to the graphing here, and let's see what we got here. Okay. All right, which one are we going to use here for a flip? I guess let's do this one. This graph's kind of cool. I got to take this other one off. All right, so let's zoom in here a bit as well. Okay, so this is a really strange function, isn't it? Okay. But what we're going to see is that if a is 1 right now, we have y equals x to the 6th plus x cubed. Okay? So if I make a -1, what should happen? It's going to reflect, right? Is it going to reflect about the y-axis? Or is it going to reflect about the x-axis? Which one's it going to do? Very good. X-axis. Yes. Well, let's just see. So we've got 1. Watch this carefully. I'm going to go to -1. Yeah, that's amazing. That's a -1. You see, we've done negative, and this is f of x right here. +1. It's a flip about the x-axis. Yeah, question? So is this This is not a parabola. No. Does it have a vertex? No, not in the sense that a parabola has a vertex. It has a minimum value here. That's a minimum point. So if you take a look at this minimum point, right about there, you can kind of keep that in your mind, right? And then see what happens when it moves, right? So here we go. Let's play that, and you see that's -1, and reflects. There's +1. So every point is reflecting about the x-axis. The y values are changing. Negative version, positive version. What is this point called right here? 0, 0. It's the origin, yes. What's the new name we gave to this point, seeing as it's the exact same point on both reflections? What's that name we just gave it? Invariant point. Yeah, everyone see that? All these other points are changing. And even though this looks like it's not changing, if we zoom in, whoa, freaky. Yes, let's go. Okay, look at that. Didn't look like it was moving at all, but it is. Look at that. Look at. You can see it. That's amazing. Where is the origin? Right there. That's not moving. Everything else is moving. Up and down. So tiny, though. How far can we zoom in? I don't know. This is super exciting. Okay, look at that. Whoa. Moving. Come on. Come on. Yes, look at that line's getting thicker. Can't see that, but I can see that. Okay? It's moving, it's reflecting. That's so awesome. I tell you, the things that excite a math teacher, this is one of those things. Look at that. Amazing. Okay, enough of that. All right. I don't know how to zoom back out now. Okay, let's just keep ripping it here. Okay, back to reality. Back to life. Back to reality. Okay, here we go. That. Still on there. Uh-oh. Houston, we have problems. Still got to go in. Can't see it yet. There we go. Hello. All right, now, this is going to be awesome. Okay, you ready for this? Let's do, this one here is, okay, that's 1. That's what the graph looks like when A is 1. Now, notice what I did down here. You see this right here? What I did was I put another parameter, and don't worry about the g. For some reason, I couldn't get it to be what I wanted to, but it's just g. So this is the same function right now. If I'm going to light this one up here, okay, you see it's the exact same function as this. But what I'm going to do now is I'm going to show you how I change the x from positive x to negative x, okay? Are you guys ready? Are you ready? Oh, anticipation. This is amazing, okay? Okay, what do you think is going to happen? It's going to, okay, I'm saying, flip. Okay, it's going to flip. Which way? Sideways or up and down? Yeah, sideways. Woohoo. So sideways. Okay? 1, let's see if you're right. Oh, just psych. Changing the wrong one. Okay, here it is. Ready? Look at that. Is that beautiful? I tell you, there's just some beauty with these majestic. I like that word too. Look at that. Flipping left to right. Okay? Let's zoom out, shall we? Let's play that puppy. Look at that. Yeah, play that puppy. Oh, what about, why don't we do this one? Let's play that one too. They're both going different speed. No, they're going the same speed. Yeah. Look at that. Why is one going faster? Okay. I guess it's, that's a good question actually. Why is one going faster than the other one, hey? It's interesting, isn't that interesting? Because the shape of the graph here, and really what's happening is these values here are causing this graph, these graphs to go to infinity or to approach 0 in some ways. Like for example, see how they're getting straighter? This blue one appears exactly straight at some point. Which point does it appear exactly straight? Or like just a straight line graph? At what value? 0, you think? Let's see. Oh, you are correct. Look at. Now does that make sense? Y equals 0 times x to the 6 plus 0 times x cubed. That's y equals 0. That's a horizontal line right through the origin, right on the x-axis. Beauty. Okay? So this line is not straight there, but it's pretty close. It's getting close to becoming y equals 0, but not quite, you see? Let's zoom in, shall we? Just kidding. You see? All right, so much information you're picking up here. That is beauty. All right, any questions so far? I got some other graphs on there. Maybe I'll show you a bit later. Oh, let's do this one. The parabolas are a little bit tough to show these flips, and I'll show you why. Okay, so let's do this. That's 1, and now a negative 1 is going to look like this, right? That's a flip upside down, right? But what about this one, where I change b from 1 to negative 1? Watch it carefully, and negative 1. Because, now it looks like the same graph, right? And actually, it is the same graph. Look at, let's go back to positive 1 here. Okay, same graph. Now, if we've flipped this, if it's reflected horizontally or about the y-axis, because a parabola, which is origin-centered here, just y equals x squared, it's symmetrical. So if you flip it, it's like it's flipping onto itself. That's why it's a little tough to see what's happening here. Right? So let's move this one again. Okay, oops, this way. See that? See, it hits the same shape. Boom. And then same shape down there. So that's why I used this kind of funny graph here where it was a bit asymmetrical, you see. Then we could actually see this happening. Sweet. Is that sweet or what? Just say yes, Mr. Maxwell, that's awesome. Yeah, thank you. Okay. Totally unsolicited praise there. It's amazing. All right, so we got reflections. We got reflections. Okay. I think that's going to be probably enough for a lesson here today on reflections anyways. The stretches I think we'll do tomorrow, but that's the lesson on reflections, about the x-axis, about the y-axis. Really important pieces of information here is that a reflection about the x-axis is this one, the negative out front of the function, and a reflection about the y-axis is the negative in the function with the x, as was illustrated by your graphs here. Okay? In your textbook here are the graphs that we did right here. So those are the graphs. And talks about the invariant points that we talked about. Stretches we're going to take a look at in the next lesson. But where am I getting to here? I'm getting to the summary page in your textbook. Very, very good summary page right here. Okay. So we took a look at the first two here in this lesson just now. Reflection of the x-axis, reflection in the y-axis, and so on. So make sure you take a look at that. The mapping we didn't really talk about too much here in this video, although I did show that on a couple screens there. But if the original function is x, y, the reflection about the x-axis is x negative y. Okay? And then over here, the other reflection is negative x, y.